Hello friends, myself R.D. Mazen presenting my video on partial differentiation revision part 1. Uh, Let us solve the first problem. If u is equal to e raised to y into y cos x minus x sin of x, then show that dou u by dou x square plus dou u by dou y square equals to 0. Here the given function is u is equal to e raised to y multiplied by y cos x minus x sin of x. We call this as equation 1. It is function of x and y, two independent variable x and y. And therefore, to show this, we have to differentiate this u with respect to x twice and then with respect to y twice. Therefore, first differentiating u with respect to x. Differentiating u with respect to x, keeping y constant. Therefore, dou u by dou x is equal to, here y is constant term, taking outside as it is. Differentiating these two terms with respect to x, the derivative of the first term with respect to x is y, constant term outside. Derivative of cos x is minus sin x. Then minus x. Derivative of sin x, applying product rule. Derivative of sin x is cos of x minus sin x, and differentiation of x is 1. This is the first order derivative of u with respect to x. Again differentiating with respect to x. Differentiating this again with respect to x. E raised to y constant term. Differentiating these three terms with respect to x. The derivative of the first term is minus y constant. Derivative of sin is cos. Applying product rule, x into derivative of cos is minus sin minus cos of x. Derivative of x is 1 and derivative of sin x is minus cos x. Simplifying it, it is e raised to y multiplied by minus y cos of x. Minus minus it becomes plus x sin of x and minus cos x minus cos x. We get 2 cos x and we call this equation 2. Then differentiating 1 with respect to y, keeping x constant. Here it is function of y. This term is as a function of y. Applying product rule, UV rule. First term e raised to y as it is. Derivative of second term with respect to y, its derivative is cos x. X sin x is constant term, its derivative is 0. Plus second term as it is. Differentiation of e raised to y is e raised to y. From this two term I can take e raised to y common. It is cos x plus y cos x plus x sin x into e raised to y. Again differentiating this with respect to y. We get dou u by dou y square is equal to a term of y. Therefore applying product rule, UV rule. First term e raised to y. Derivative of this second term with respect to y. Constant term is derivative 0. Derivative of second term is cos x. X sin x is constant term, its derivative 0. Plus second term as it is cos of x plus y cos x minus x sin x. Differentiation of e raised to y with respect to y is e raised to y. from these two terms, I can take e raised to y common. Therefore, e raised to y multiplied by cos x plus cos x, we get 2 cos x plus y cos x and minus x sin x. We call this equation 3. Therefore, I have obtained two results. One is for dou tu by dou x square. We are calling it as second equation. And third equation for dou tu by dou y square. Then adding this 2 and 3, addition of left hand side and adding right hand side term, we get dou tu by dou x square plus dou tu by dou y square is equal to, therefore, e raised to y into minus y cos x plus x sin x minus 2 cos x. We add with this. Therefore, if you see the terms, minus 2 cos x and this plus 2 cos x get cancel. Y cos x cancel with minus y cos x and x sin x cancel with minus x sin x. Therefore, when we take the addition of equation 2 and equation 3, its sum is 0. And therefore, we get the required result. Dou tu by dou x square plus dou tu by dou y square equals to 0. Second example, if u is equal to log of x cube plus y cube plus z cube minus 3 times xyz, then show that dou by dou x plus dou by dou y plus dou by dou z and bracket square operated on u is equal to minus 9 divided by x plus y plus z bracket square. And therefore, to obtain this, if we see u is a function of u is a function of log, and log is function of three independent variable x, y, z. Therefore, differentiating this first with respect to x, differentiating 1 with respect to x, keeping y and z constant, derivative of u with respect to x is dou u by dou x. Derivative of log is 1 upon x cube plus y cube plus z cube minus 3xyz. Chain rule, differentiating this with respect to x, keeping y and z constant, derivative of x cube is 3x square, y and z is derivative 0. Differentiation of this last term is minus 3yz. Rewriting it by taking 3 common, we get 3 times x square minus yz whole divided by x cube plus y cube plus z cube minus 3xyz. We call this equation 2. And as the terms are in similar form, means cube of x, cube of y, cube of z and 3xyz, we can write down similarly. We get differentiating u with respect to y, keeping x and z constant, we get 3 times. For differentiation with respect to x, we are getting a term of x square. Here we get a term of y square. And second term without x, therefore here it is without y, means xz, and whole divided by x cube plus y cube plus z cube minus 3xyz as equation 3. And result for dou u by dou z means differentiating u with respect to z, keeping x and y constant term, we get 3 times. For z, first term is z square minus second term without z, therefore it is xy, and whole divided by x cube plus y cube plus z cube minus 3xyz as equation 4th. Equation 2, 3, 4. by 2 plus 3 plus 4, we get dou u by dou x plus dou u by dou y dou u by dou z is equal to, if you observe the term in denominator is same for all the three terms, therefore taking LCM as that, it is x cube plus y cube plus z cube minus 3xyz, and then addition of numerator term 1, 2, 3. Therefore, it is 3 times 3 we can take common, x square plus y square plus z square minus yz minus xz minus xy, we get, we know this result, a cube plus b cube plus c cube minus 3 times abc as a plus b plus c multiplied by a square plus b square plus c square minus ab minus bc and minus ca, and therefore applying this result, this we can rewrite as, therefore that dou u by dou x plus dou u by dou y plus dou u by dou z as a numerator term I will keep as it is, that is 3 times x square plus y square plus z square minus yz minus xz minus xy whole divided by, this we can simplify using this result as a plus b plus c means it is x plus y plus z multiplied by a square means x square plus y square plus z square minus ab means minus xy minus yz and minus xz, and therefore this term get cancelled with this term and we get that value as 3 divided by x plus y plus z as equation number 5. And therefore the required result, therefore that dou by dou x plus dou by dou y plus dou by dou z square operated on u, we can rewrite as, it is square means the same operator is operated twice, therefore it is dou by dou x plus dou by dou y plus dou by dou z operated on dou by dou x plus dou by dou y plus dou by dou z operated on u, and therefore it becomes dou by dou x plus dou by dou y plus dou by dou z, outer term I am keeping as it is, then operating this on u, we get that term as dou u by dou x plus dou u by dou y plus dou u by dou z, and then substituting the value from equation 5th, it becomes dou by dou x plus dou by dou y plus dou by dou z. The value of this is 3 times, 3 divided by x plus y plus z. Therefore, operating term by term, differentiating this term with respect to x, then with respect to y, and then with respect to z, we get that value as derivative of 1 by x is minus 1 by x square. As per that, it becomes minus 3 upon x plus y plus z bracket square into chain rule. Differentiation of this term with respect to x, derivative of x with respect to x is 1 into 1, and derivative of y and z is 0, as it is constant term. Similarly, differentiating this second term, we get minus 3 upon x plus y plus z bracket square into chain rule. Derivative of y with respect to y is 1. And differentiating the same term with respect to z, we get minus 3 divided by x plus y plus z whole square, and chain rule, differentiation of this term with respect to z is 1. And therefore, adding all these three terms, minus 3 plus minus 3 plus minus 3, we get that value as minus 9 whole divided by x plus y plus z whole square as the required answer or the required result. Important one is this formula here. Example number 3rd. If theta is equal to t raised to n multiplied by e raised to minus r square by 4t, then find the value of n which will make this relation as equal. That is, dou theta by dou t is equals to 1 by r square into dou by dou r of r square into dou theta by dou r. And therefore, to apply this result, we have to differentiate theta with respect to t, means we have to find the left hand side, and then to find the right hand side, we have to perform this step. First, multiply by r square, then differentiate it by r, and then multiply it by 1 by r square. Therefore, differentiating with respect to t, differentiating 1 with respect to t, keeping r constant. Therefore, here it is function of t. Second term is also containing term of t. Therefore, we have to apply product rule, UV rule, to get the value of dou theta by dou t. First term t raised to n. Derivative of e raised to x is e raised to x into a. As per that, it is e raised to minus r square by 4t, chain rule. Differentiation of 1 by t is minus 1 by t square, and therefore it become that minus and this minus, it become plus r square divided by 4t square, plus second term e raised to minus r square by 4t, and differentiation of this term with respect to t is n t raised to n minus 1, standard result. Simplifying it, we get this is equals to 1 by 4 t raised to n divided by t square, it becomes t raised to n minus 2, transferring this term to numerator, into r square into e raised to minus r square by 4t, plus n times t raised to n minus 1 e raised to minus r square by 4t. We call this as equation number 2. This is the value of left hand side. Dou theta by dou t. Then differentiating equation 1 with respect to r, keeping t constant. Therefore, differentiating 1 with respect to r. This one is constant term. Therefore, dou theta by dou r, t raised to n constant outside. Differentiation of this term with respect to r is e raised to minus r square by 4t. Chain rule. Differentiation of this term with respect to r, 1 by 4t minus 1 by 4t. Therefore, constant term outside, and derivative of r square is 2r, and therefore it becomes minus 2r divided by 4t. Simplifying it, sign is minus. 2 by 4 we get 1 by 2 r, t raised to n divided by t, we get t raised to n minus 1, and into e raised to minus r square by 4t. Then whatever that result, we have to multiply it by r square, and therefore multiplying by r square on both sides, we get r square into dou theta by dou r is equal to, multiplying this by r square, that r and r square will become r cube, therefore it becomes minus 1 by 2 r cube t raised to n minus 1 e raised to minus r square by 4t. Differentiating this term with respect to r. Therefore, it is dou by dou r of r square dou theta by dou r is equals to, a constant term we take outside, minus 1 by 2 t raised to n minus 1. These two are constant term outside, and remaining term we have to differentiate with respect to r by applying product rule. Therefore, first term r cube, derivative of this term with respect to r is e raised to minus r square by 4t. Chain rule. Differentiation of this term with respect to r, minus 2r divided by 4t, plus second term as it is. Second term is e raised to minus r square by 4t chain rule, into derivative of r cube with respect to r, it is 3r square. Then whatever this, we have to multiply by 1 by r square. Therefore, multiplying it by 1 by r square and multiplying it by 1 by r square, we get 1 by r square dou by dou r of r square into dou theta by dou r is equal to, multiplying by 1 by r square inside the bracket, r square cancel, r remaining, this minus and this minus, it become plus. 1 by 2 into 1 by 2, it become 1 by 4 t raised to n minus 2 r into r, it become r square, and e raised to minus r square by 4t as the first term. Once again check it, multiply this by 1 by r square inside, minus minus it become plus. 1 by 2 into this 1 by 2, it become 1 by 4 t raised to n minus 1 divided by t, it become t raised to n minus 2 r cube divided by r square, r remaining, and into this r, it become r square, and e raised to minus r square by 4t. And second term becomes r square get cancelled, it is plus this is with minus sign minus 3 by 2 t raised to n minus 1 into e raised to minus r square by 4t, and we call this equation 3. Equating equation 2 with equation 3, dou theta by dou t is 1 by 4 t raised to n minus 2 r square e raised to minus r square by 4t plus n times t raised to n minus 1 e raised to minus r square by 4t, and that is equals to this value 1 by r square dou by dou r of r square dou theta by dou r, nothing but equation 3. That equation 3 is 1 by 4 times t raised to n minus 2 r square e raised to minus r square by 4t minus 3 by 2 t raised to n minus 1 multiplied by e raised to minus r square by 4t. Therefore, comparing these two sides, 1 by 4 t raised to n minus 2 r square e raised to minus r square cancel with this same term, t raised to n minus 1 e raised to minus r square by 4t, same term. Therefore, comparing the coefficient of this term is n. Therefore, we get n is equal to the coefficient of the same term on the right hand side is minus 3 by 2. Therefore, we get the value of n as minus 3 by 2, obtained by comparing the two sides, left hand side compared with the right hand side term. Therefore, in this video, I have discussed 3 simple examples of partial differentiation. In my next video, I will discuss some more examples on partial differentiation. If you like my video, please share it as well as subscribe to my channel to receive the notification of my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.